Let's solve practice set 5.1. Question first. Find the distance between each of the following pairs of points. Sub question first. A23, B41. Practice set 5.1. Question first. Sub question first. Solution. Let A23 is x1 y1, b41 is x2 y2. Okay, therefore by distance formula AB equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root x2 is 4 minus value of x1 is 2, 4 minus 2 bracket square plus y2 value of y2 is 1 minus y1 value of y1 is 3, 1 minus 3 bracket square equals under root 4 minus 2 square means 2 square plus 1 minus 3 bracket square means minus 2 square equals under root square of 2 is 4 plus square of minus 2 is also 4 equals root 8 equals root 4 into 2, and therefore AB equals 2 root 2, that is distance between A and B is 2 root 2. Okay. Sub question second. Solution. Let P minus 5 7 is x1 y1 and Q minus 1 3 is x2 y2. Therefore by distance formula PQ equals under root x2 minus x1 square plus y2 minus y1 square is equals under root value of x2 is minus 1 minus 1 minus value of x1 is minus 5 minus 1 minus minus 5 its square plus value of y2 is 3 minus value of y1 is 7 bracket square equals under root minus 1 minus minus 5 means minus 1 plus 5. Okay, minus 1 plus 5 gives us 4 its square plus 3 minus 7 bracket square means minus 4 its square equals under root 16 plus 16 equals under root 32 equals under root 16 into 2. Therefore PQ equals 4 root 2, that is distance between P and Q is 4 root 2. 4 root 2. Sub question third. Solution. Let R0 minus 3 is x1 y1 s 0 5 upon 2 is x2 y2. Therefore, by distance formula, RS equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root value of x2 is 0 minus value of x1 is 0, 0 minus 0 square plus value of y2 is 5 upon 2 minus value of y1 is minus 3, its square is equals under root 0 square plus 5 by 2 minus minus 3 means plus 3, its square is equals under root square of 0 will be 0 plus 5 by 2 plus 3, its square. 2 3s are 6, 6 plus 5 11 upon 2 its square. Therefore, RS equals under root 11 upon 2 bracket square means 11 upon 2. Therefore, distance between R and S is 11 upon 2. Sub question 4th. Solution. Let L 5 minus 8 is x1 y1, M minus 7 minus 3 is x2 y2. Therefore, by distance formula, LM equals under root x2 minus x1 square plus y2 minus y1 square is equals under root minus 7 minus 5 square plus minus 3 minus 8 its square is equals under root minus 12 square plus minus 3 minus 8 bracket square means minus 3 plus 8 bracket square. Minus 3 plus 8 gives us plus 5. Its square. Square of minus 12 is 144 plus square of 5 is 25 is equals under root 169 and therefore LM equals 13 and therefore or we may say that is distance between LM is 13. Sub question 5th. Solution. Let T minus 36 is x1 y1 R 9 minus 10 is x2 y2. Therefore, by distance formula, TR equals under root x2 minus x1 square plus y2 minus y1 square is equals under root 9 minus minus 3 bracket square plus minus 10 minus 6 bracket square is equals under root 9 minus minus 3 means 9 plus 3. 9 plus 3 12 its square plus 10 minus 10 minus 6 means minus 16 its square is equals under root square of 12 144 plus square of minus 16 is 256. Okay, equals under root 4 plus 6 10 carries 1 5 and 1 6 6 and 4 again 10 carries again 1 2 and 1 3 and 1 4. TR equals under root 400 and therefore TR equals 20. That is distance between T and R is 20. Sub question 6th. Solution. Let W minus 7 upon 2 4 is x1 y1 and x 11 4 is x2 y2. Therefore, by distance formula, Wx equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root 11 minus minus 7 upon 2 its square plus 4 minus 4 its square is equals under root 11 minus minus uses plus 7 upon 2 its square plus 4 minus 4 uses 0 its square is equals under root. Denominator of 11 will be 1, then 2 11s are 22, 22 plus 7 uses 29 upon 2 its square plus square of 0 will be 0 and therefore Wx equals 29 upon 2, that is distance between W and X is 29 upon 2 equals 2 1s are 2, 2 4s are 8 and 2 5s are 10. Therefore, distance between W and X is 14.5. Okay. Question second, determine whether the points are collinear. Question second, sub question first, solution. Let A1 minus 3, B2 minus 5, C minus 4, 7 are given points. Okay. Let A 1 minus 3 is x1 y1, B 2 minus 5 is x2 y2, C minus 4 7 is x3 y3. Therefore, by distance formula. By distance formula, AB equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root 2 minus 1 square plus minus 5 minus minus 3 square equals under root 2 minus 1 means 1 its square plus minus 5 minus minus 3 means minus 5 plus 3. Minus 5 plus 3 gives us minus 2 its square equals under root 1 plus 4 equals root 5. Therefore, AB equals root 5. Let's call it as equation 1. Similarly, BC equals under root x3 minus x2 bracket square plus y3 minus y2 bracket square is equals under root minus 4 minus 2 bracket square plus 7 minus minus 5 bracket square is equals under root minus 4 minus 2 gives us minus 6 its square plus 7 minus minus 5 means 7 plus 5, that is 12 its square. Okay, that equals under root square of 6 is 36 plus square of 12 144 equals under root 180. Okay, 180 we may split as 5 into 5 3s are 15 and 5 6s are 30, and therefore BC equals 6 root 5. Equation second. AC equals under root x3 minus x1 square plus y3 minus y1 square is equals under root minus 4 minus 1 its square plus 7 minus minus 3 its square equals minus 4 minus 1 gives us minus 5 and minus 5 its square is 25 plus 7 minus minus 3 means 7 plus 3, that is 10, and square root of 10 is 100, that equals under root 125, and root of 125 is 25 fives. Therefore AC equals 5 root 5. Equation third. Okay, first equation tells us AB equals root 5. Second equation tells us BC equals 6 root 5. And equation third tells us AC equals 5 root 5. Okay, and therefore from 1, 2 and 3, therefore from 1, 2, 3, yes, 6 root 5 is the longest distance and rest of two distances are root 5 and 5 root 5. Addition of root 5 with 5 root 5 is 6 root 5. Means sum of the lengths of two smaller distances is equals greater distance. And therefore points are collinear. We will mention here from 1 to 3. From 1 to 3 we may write there root 5 plus 5 root 5 equals 6 root 5. That is root 5 is a length of AB plus 5 root 5 is a length of AC is equals 6 root 5 is a length of BC, and therefore A comma B comma C are collinear such that as B and C will be at extremes, B dash A dash C will be the betweenness. Question second, sub-question second, solution. Okay, here we have to determine whether the points are collinear. Sub-question second, solution. Let L minus 2, 3 is x1, y1, M 1 minus 3 is x2, y2, and 5, 4 is x3, y3. Therefore, by distance formula, Lm equals under root x2 minus x1 square plus y2 minus y1 square equals under root 1 minus minus 2 its square plus minus 3 its square equals under root 1 plus 2 its square means 3 square plus minus 6 square under root 9 plus 36 equals root of 45 equals root of 9 into 5 equals 3 root 5. Therefore, Lm equals 3 root 5 dash equation first. Similarly, Mn equals under root x3 minus x2 bracket square plus y3 minus y2 bracket square is equals under root 5 minus 1 bracket square plus 4 minus 3 bracket square equals under root 4 square plus 7 square equals square of 4 is 16 plus square of 7 is 49 equals root of 9 plus 6 gives us 15, carries 1, 4 and 1, 5 and 1, 6, root of 65. And 65 at the most we may factorize as 13 into 5. Neither 13 nor 5 are perfect squares, That's why let's keep mn equals root 65. Equation second. ln equals under root x3 minus x1 bracket square plus y3 minus y1 bracket square is equals under root 5 minus 2 bracket square plus 4 minus 3 bracket square is equals under root 5 minus 2 means 5 plus 2, and 5 plus 2 its square plus 4 minus 3 means 1 its square equals under root 7 bracket square plus 1 bracket square, square of 7 is 49 plus square of 1 is 1, root of 50 equals root of 25 into 2, and therefore ln equals root 50 equals 5 root 2. Equation third. And therefore from 1 to 3, okay, 1 tells us ln equals 3 root 5 means root 45, mn root 65 and ln root 50. Greatest distance is root 65 and rest of two are root 45 and root 50. Okay, and from 1, 2 and 3 sum of smaller distances means which 3 root 5 plus 5 root 2 is not equals greatest distance, that is distance root 65, that is ln plus ln is not equal to mn, and therefore l comma m comma n are not collinear. Okay, are not collinear. Question second, sub question third. Solution. Let R03 is x1 y1, D21 is x2 y2, S3 minus 1 is x3 y3. Therefore, by distance formula, RD equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, let's put values. Is equals under root 2 minus 0 its square plus 1 minus 3 its square equals under root 2 square plus minus 2 square equals under root 4 plus 4 equals root 8, and root 8 equals root 4 into 2, and therefore RD equals 2 root 2. Equation first. Similarly, ds equals under root x3 minus x2 bracket square plus y3 minus y2 bracket square is equals under root 3 minus 2 its square plus minus 1 its square equals under root 1 square plus minus 2 square equals 1 plus 4 equals root 5. Therefore, ds equals equation second. Rs is equals under root x3 minus x1 bracket square plus y3 minus y1 bracket square is equals under root 0 minus 3 its square plus minus 1 minus 3 its square equals under root minus 3 square plus minus 4 square. Square of minus 3 is 9 plus square of minus 4 is 16 equals under root of 25, and therefore Rs equals 5. Equation third. Okay, now from 1, 2 and 3. From 1, 2 and 3. You may note Rd, which is 2 root 2 means root 8. Ds, which is root 5, and Rs, which is 5, means root of 25. Root of 25 is the greatest distance, and rest of two distances are root 8 and root 5. Okay, and as root 8 plus root 5 is not equal to root 25, we can conclude points RDS are not collinear. Okay, let's mention here from 1, 2 and 3. What from 1, 2 and 3? Root 8 plus root 5 is not equals root 25. That is 2 root 2 plus root 5 is not equal to 5. That is RD plus ds is not equals Rs. Therefore, RDS are not collinear. Are not collinear. Okay. Question second, sub question fourth. Solution. Let P minus 2, 3 is x1, y1, Q 1, 2 is x2, y2, R 4, 1 is x3, y3. Therefore, by distance formula, PQ equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root 1 minus minus 2 its square plus 2 minus 3 its square is equals under root 1 minus minus 2 means 1 plus 2 and 1 plus 2 is 3 its square plus 2 minus 3 gives us minus 1 its square is equals under root square of 3 is 9 plus square of minus 1 is 1 equals root 10. Therefore, PQ equals, let's call it as equation first. Similarly, QR is equals under root x3 minus x2 bracket square plus y3 minus y2 bracket square is equals under root 4 minus 1 its square plus 1 minus 2 its square is equals under root 3 square plus minus 1 square is equals under root 9 plus 1 equals root 10. Therefore, QR equals root 10. Let's call it as equation second. PR equals under root x3 minus x1 square plus y3 minus y1 square is equals under root 4 minus minus 2 its square plus 1 minus 2 its square is equals under root 4 minus minus 2 means 4 plus 2 its square means 6 square plus 1 minus 3 1 minus 3 and 1 minus 3 is minus 2 its square equals 36 plus 4 equals root of 40 and root of 40 means root of 4 into 10 equals 2 root 10 equation third. Therefore, PR equals and therefore from 1, 2 and 3 okay distances are root 10 and 2 root 10 and we know that root 10 plus root 10 gives us 2 root 10 okay from 1, 2 and 3 root 10 plus root 10 equals 2 root 10 that is PQ plus QR equals PR and therefore PQR are collinear such that P dash Q dash R. Okay.